All right, in our next video, we are going to look at relating P of A to the remainder of P of X divided by X minus A. So that is all very technical. I'll come back to that once we go through an example and kind of make sense of what we're seeing. So we are going to take a function P of X and we're going to divide it by X plus 5. So because this is an x to the first power, plus or minus a number, we can use synthetic division. What we want to figure out is that a value. Remember this a value, it's x minus something that ended up with x plus 5. So our a value is a negative 5. That tricky x idea again. If you're dividing by an x plus 5, that a value for synthetic division is a negative 5. So when we set up our synthetic division, we're going to put negative 5 in our little box in the corner. We're going to write out the coefficients of our dividend. Let's make sure we're not missing any terms. We have x to the third, x squared, x to the first are constant. So we have all of our terms. When we write out the coefficients, we have a 1 with the x cubed, a 10 with the x squared, a 29 with the x, and a 24 as our constant term. Leave space to write some numbers below this, draw a line, and let's start our synthetic division. The first number always gets carried down first. Now we start multiplying and adding down, multiplying and adding down. So this 1 gets multiplied with the negative 5. 1 times negative 5 is negative 5. That goes below our next term. Now we add down. 10 plus negative 5 is 5. Now let's take this 5 times our negative 5 and we get negative 25 and we add down. 29 plus a negative 25 is 4. We keep going with that pattern. 4 times negative 5 is negative 20. Add down and you get a 4. Circle that last number, make a note, that's your remainder. And then let's fill in moving to the left. This is our constant term. This is our x to the first power term, and this is our x squared term. So our dividend, P of x, I'm not going to rewrite the whole thing. P of x is equal to the product of what we were dividing by. So remember we divided by an x plus 5, and we got this x squared plus 5x plus 4. And we have a remainder of 4. So there's that remainder right there. Okay, so what they want us to do now is let's find P of A. So P of A, remember up here we said A was negative 5. So what happens if we plug a negative 5 into our function right here? So we're going to plug in a negative 5 for every x that we see. This is going to give us negative 5 plus 5 times negative 5 squared plus 5 times negative 5 plus 4, and then that plus 4 on the end. So we have a product of these two parentheses and then the plus 4 in the end. So when we get that product, negative 5 plus 5 is 0. That's going to happen every time. Your a value, if you plug that in to this part of what we were dividing by, it's always going to give you a 0. And then 0 times, I mean, we can do the math if you want, but I don't even care what's in here. I'll just tell you, if you simplify all that, you get 25 minus 25 plus 4, which is 4. And then we have that plus 4 on the end, because 0 times anything is going to give us 0, and then plus 4. And if we evaluate our P of negative 5, we have that 4 right there. So what we want to notice is that when you do your synthetic division, and then if you evaluate your answer for that a value, if you plug that a value in, you're going to just be left with your remainder every single time. It's going to equal your remainder. That's the thing we wanted to notice on this one. So what's nice about noticing all of that is now this gives us a remainder theorem. The remainder theorem states that if a polynomial is divided by x minus a, the remainder, oops, is p of a. The factor theorem states that the expression x minus a is a factor of a polynomial p of x if and only if p of a equals 0. So whatever our a value is, if you plug it into your polynomial and you get 0 back, that means that x minus a was a factor of that polynomial, because that meant there was no remainder. It was a nice clean factor.